So for this example, we're now going to be looking at interpreting exponential functions. So the directions here state that we're going to determine whether each function represents exponential growth or exponential decay. And we're going to identify the initial amount and the percent rate of change. So exponential growth, remember that is when b is greater than 1. Exponential decay, that's when it's between 0 and 1. So I'm going to first look to see whether it's exponential growth or decay. So remember my b value is what is inside the parentheses. I see that 0.92, that is less than 1. So that means that this is decay. And that's because 0.92 is less than 1. So I got my first answer. Next, I need to figure out the initial amount and the percent rate of change. Well, the initial amount is always that number in the front. So I know that a is equal to 2. That's my initial amount. Now I need to figure out the percent rate of change. And so for that, I need to look at how I got that 0.92. So looking back at our facts over here, our decay facts, I know that what's in the parentheses is 1 minus my percent rate of change right now as a decimal. So 1 minus r gets me that 0.92. So to find what my rate is, all I'm going to do is take 1 minus 0.92. And when I do that, I get 0.08. But I need to change that to be a percent because it's asking for the percent rate of change. So to change a decimal to a percent, I'm just going to take this decimal point and move it forward 2. And so I get 8%. So this function is a decay. My starting value is 2. The percent rate of change is 8%. Okay, let's try this again. So looking at number 2, I'm going to first determine whether it is a growth or decay. Looking at 1.2, that is bigger than 1. So that means that this is growth. Next, I'm going to look for my initial amount. Here, it's a little bit tricky. There's no number in front there. Well, whenever there's no number, there's really an imaginary 1 there, because 1 times this is going to get you that. And so that means that a is equal to 1. My initial amount is 1. Now I need to figure out my percent rate of change. So since this one's growth, what's in the parentheses is whatever is 1 plus my rate of change. So I know that 1 plus r gets me the 1.2. And so to figure out my rate, I'm just going to take 1.2 minus 1. And so I get 0.2. But again, I need the percent of that, so I need to move this forward 2 places. And I notice I ran out of numbers here, so whenever I run out of numbers, I just put a 0 there. So this is going to be 20%. And those are my 3. So when it's decay, to find your rate, you'll just do 1 minus whatever b is. When it's growth, you'll flip-flop that, so you'll do b minus 1, because you're not supposed to get a negative either way. That is it for this video. You can go ahead and move to the last one where we'll be looking at some application problems.